Hi everyone, and thank you so much for those of you that tried the 8-1 Explore activity yesterday, investigating systems of equations. So it says you have learned several ways to graph a linear equation in slope-intercept form. For example, you can use the slope and the y-intercept, or you can find 2 points that satisfy the equation and connect them with a line. So on part A, you're supposed to graph. Sorry, I ran a little bit. Graph the pair of equations together. Y equals 3x minus 2 and y equals negative 2x plus 3. And once again, remember the slope-intercept form of an equation is y equals mx plus b, where m is the slope and b is the y-intercept. So here, the m, the number that is the coefficient of the x, is the slope, and the constant, the number that is by itself, is the y-intercept. Now, I'm going to go ahead and copy and paste them because I'm going to graph it, Control C. And here I posted if you click in here and you click Edit, okay, it's going to take you to Google Drawings. And so right here, that's where you graph them. Let me see if it'll paste my things. Oops, right there. So these are my equations. So now what I should have done was, okay, one of these is going to be in red and one of them is going to be in blue. So I'm going to start graphing this one first. And the y-intercept is negative 2. So I'm going to make a line. Line. And then I'm going to, the color, is it going to let me? Okay. So I'm going to try a black first. So the y-intercept is negative 2. So negative 2, this is the y-axis. This is 0, 1, 2. Negative 2 is right there. And the slope is 3. So from here, negative 2, I'm going to go rise 3, 1, 2, 3, and then run 1. So it's going to hit that point, and then 1, 2, 3, and then run 1 is going to hit that point. If I go down 1, 2, 3, and run 1, it's going to hit that point. So I'm going to start right here, and then I'm going to do slope 1, 2, 3, run 1. Sorry, let me do it again. 1, 2, 3, run 1, 1, 2, 3, run 1, 1, 2, 3, run 1, and I'm going to put it right there. Okay, so that is the equation for this one. Okay, so now I'm going to graph the other equation, and I'm new to this. I am learning just like you guys are. So graph, let me see if it lets me change. Oh, line color. Okay, now I'm going to, oh, it's going to do that for that one. Okay, so now I'm going to do another line, and I'm going to do this one. The y-intercept is 3 and the slope is negative 2. So positive 3 for the y-intercept. This is the y-axis. 1, 2, 3. And the slope is negative 2. So that means I go down 2 over 1. Oops, that's where they're going to intersect. Down 2 over 1. So I'm going to go ahead and just, since I already found where they intersect, I'm just going to make it small right there. Down 2 over 1. They're already different colors. So I'm not going to go ahead and change the color on that one. So this is for the first one, and then this is for the second one. Okay, so now I know that they intersect at the point 2-1. That's the solution of the systems. Okay, now I'm going to go to save and close, and it's going to be right there, and I do check it. Okay, so please do it right. So now it says explain how to tell whether 2, -1 is a solution to this equation. So without using the graph, you can substitute the value of x and y in the equation. So let me show you. So if they tell you that the solution is 2, -1, or that point is right there, you start off y equals you start off by writing the equation, y equals 3x minus 2. Then you're going to substitute. Remember, when you have the ordered pair, the first one is x, the second one is y. So it's always x, y. So now I'm going to substitute. Instead of y, I'm going to put in -1 equals 3 times, I'm just bringing it down from the top, and then the x is 2. So I put 2, close parentheses, and then there's a -2. Then on this side, there's nothing I can do, so it's just a -1. On the other side, what stands out to me is the parentheses first. So I multiply 3 times 2, that's 6, and then -2, that's going to give me 4. So -1 equals 4. It's not equal, okay? So therefore, it is not a solution, okay? Okay. False statement. Oops, misspelled. False statement. So 2, -1 is not a solution of the equation y equals 3x minus 2. Okay, so you can also see it on the graph. Let me show you. So 2, -1, 2, -1. The point 2, -1 right here, it's on this line, but it's not on the orange line. So 2, -1 is a solution of this equation, but is not a solution of this one because it is not on their line, okay? So save and close. Let's go to the other one. So it says explain how to tell without using the graph. The same thing, okay? So I'm just going to copy and paste and then change it when I need to, okay? Because it's going to be the same answer. Control copy, control paste, but it says without using the graph, you can substitute into the equation. So I did that one, but the equation is going to be different. This one's going to be -2, and then it's going to be +3. I'm trying to maximize my time. So now here, the y again is -1 from there. This one's going to be actually -2, and then the x is still 2, and then instead of -2 is going to be +3. So I put +3. Then here, -2 times 2 is -4, -4, and then +3. Right here, brought the 3 down. On this side, once again, you just put -1. Now, -4 plus 3, I have 4 negatives and 3 positives. I'm going to make 3 zeros, so I'm going to have 1 left over, so it's going to be -1. This is actually a true statement. -1 is equal to -1, so we say true statement. So 2, -1 is a solution of the equation y equals, remember, -2x +3, okay? Now, it says use the graph to explain whether 2, 1 is a solution of each equation. Well, I showed you already. So on the graph, 2, -1 is going to be on this line, which is the line for this equation, y equals -2x +3, but it is not on the line for this equation, which is y equals 3x minus 1, okay? So use the graph. So 2, -1 is on the line for the equation y equals 3x minus 2, but it is not on the line for the equation y equals, oh wait, it was not on this. Oh, okay. 2, -1 is not on the line for the equation y equals 3x minus 2, but it is on the line for the equation y equals -2x plus 3. Okay, therefore, it is a solution to the equation y equals negative 2x plus 3. Okay, so remember that these equations have infinitely many solutions. All the points on the graph are the solutions. Okay, now determine if the point of intersection is a solution to both equations. So where do they intersect? Okay, so we go back in here and they intersect at 1, 1. So that's the point of intersection. So I'm going to put right here, point of intersection is 1, 1, 1, and 1. So that's where the point of intersection. So now we're going to substitute it in here. Well, my y value is 1. So right here, let me see, my y value is 1. My x is 1. Some of you struggle with just multiplying right here. So look, 3 times 1 is 3. Minus 2, this is 1. So I put 1. It's a true statement, so it is a solution for this equation. Now I got to try it over here. The y, once again, the y right here is 1, so I put 1. My x is 1, so I'm going to put x is, 1. So 2, there's a negative 2 right there. Okay, sorry, I missed it on there. And I did make a mistake. I had to go to each of your assignments and put negative 2 right there. So negative 2 times 1 is negative 2 plus 3 is 1. This is a true statement, so therefore it is a solution to the whole system. Okay, so the point of intersection is the solution of both equations. Okay, thank you so much.